Hi, and welcome to Circuits Part 3. In this part of our explanation of this complex circuit, so far we've already calculated our equivalent resistance and our voltage drop across this fourth resistor. If you have questions on where we came up with those numbers, you can see Circuits Part 1 or Circuits Part 2 to get up to speed on that information. If we're okay with the calculations so far, we're now going to take a look and see how we can use our voltage drop across each branch of our loop to calculate what the current is passing through each of these resistors. So let's take a look. Our voltage drop across each branch is going to be 20 volts. And if we remember from Circuits Part 2, the way we calculated that is based on the fact that our voltage drop for the entire circuit is a total of 30 volts. And the voltage drop through this fourth resistor, as we calculated, and we see written up there in the top right corner, is 10 volts. So if it's a 10 volt voltage drop through this circuit, that means the voltage drop across each branch of this loop, the rest of the circuit, has to be 20 for our total voltage drop to be 30. And we see that calculation right here. So let's take a look at resistor 1 and see if we can calculate the current through that resistor. Again, current through resistor 1 is going to require us to use Ohm's law, which, as we have written up top, is V equals IR. So your current will equal your voltage divided by your resistance. And in this case, we're going to simply plug in our values. Our voltage drop across each branch of our loop is a total of 20 volts. So our voltage drop through this resistor is 20. The resistance, we see 60 ohms. So the resistance of that resistor is 60. And this will give us a total current, when we reduce that, of 1/3. So there's 1/3 of an amp passing through this top branch of our loop. And because when current splits, it might not split evenly, but the total has to sum to whatever the current is arriving at your intersection. That means if 1/3 of an amp goes this way, and our total current entering the intersection is 1 ampere, then that means that the current passing through this branch of our loop will be 2/3. So if we have 1/3 up here, then by definition, as one of Kirchhoff's rules, that means that we have 2/3 of an amp passing through this lower branch of our loop through resistor number 2 and resistor number 3. That allows us to find current across each of our resistors in our entire circuit. We've also calculated our equivalent resistance and our voltage drops. If we have questions on any of those calculations or want more information, please feel free to visit our website, www.sandersontestprep.com. The link is in the description below. And also feel free to comment and suggest further topics and subjects that you'd like to see covered. Thanks.